Learning about in this process is that, like I said, for the next unit, the piece of paper I'm going to give you is going to lay out then the lecture schedule, and that will then also relate to then the learning objectives and also relate to the homework assignment, so that you will know ahead of time then what I'm going to be talking about, what I'm talking about, when I'm talking about it, and what homework assignments it's related to. I think that'll help, right? Because that's one of the other part of our confusion in this, right? Is this thing working? Hello? Okay. Good. All right. So then today, my little lecture for today, I'm hoping to take 15 minutes. I'm hoping is to talk about the relationship between populations, communities, ecosystems, and then also be looking at symbiotic relationships. I know some of you have already got this stuff. Others of you haven't. But again, I need to make sure that I'm teaching you all the things that I know that you need to be learning, okay? Now, one of the things I'm also going to try to do for today is to type my notes for you. Would that help? So that you can read it. Would that be beneficial for you?
Yes.
Wonderful. Thank you very much for that feedback. I appreciate it. So, I am going to leave the light, the front light, would it help to keep the front light on? Well, actually, I do need to videotape it too. Turn it off. Turn it off? Okay. Can you still see me? Is it okay? All right. So here we go. So go into Canvas. Go into Canvas, go into Ecology. And this is then the, I think it's actually the bottom thing in the Ecology unit. I believe it says 10.3, 10.4. It's like note guide, daily note guide, I think is what it is. 10.3, 10.4 daily note guide. Is that what it says? 10.4, 10.5. Thank you. 10.4, 10.5 lecture notes, because today's 10.4. Tomorrow's 10.5. So I'm giving this lecture today and tomorrow. Okay? Please open this up in Notability. Now remember, ladies and gentlemen, the thing with this, when you open into Notability, okay? You can write it right on it, yes, if you want to, but you're not turning this in, so this is just notes for you, right? But you're right, you can do that as well. Remember, if you're going to put it in Notability, the one thing that you have to do at the very beginning is at the top, it's going to say pages or something like that. You need to click that because it's actually 2 pages. The default setting now with the Canvas upgrade is just the first page. So you've got to make sure it's 2 pages long. If it's not 2 pages long, then you only got the first page of it, okay? So, here we go. I've tried to then put a nice little picture on here to kind of get us started with things. There's a nice little visual representation of what we're talking about today. And it actually has all the different things in here. Now, when we start talking about populations and communities and ecosystems, really what we're talking about is how matter gets organized. And when we start looking at populations and communities and ecosystems, we're actually looking at the bigger end of that spectrum. But we can actually go smaller into that spectrum, and we can be looking at the atom and the cell and tissues and organ systems and organisms. So when we have an organism, we are still talking about how life gets organized. And that's where we're kind of joining into this thing. The organization of living things in the environment. Okay? So, as we go through this, now I'm going to put these notes in here for you. Can everybody see this? Is this big enough for you to be able to see? Yes? Okay. And I'm even going to choose a different text color just so that we can all see that as well. Where's my text colors? More text color. Red, does that work? Red. Okay, there we go. So we'll get that out of there. Population is a number, and now this is where you guys are going to have to bear with me, number of the same species living in the same place and same time. Okay? The number of same species. And that's the key to this one. And I'm going to look at how I'm going to do this here. I'm going to bold that. There we go. Same species. And why didn't this do my red thing? That's okay. Number of same species living in the same place and same time. There we go. Okay? That would be considered our population. Or it's the number of same organisms, which is really going to be the same species. If you want to put that in parentheses there, we could go organisms. Okay? Living at the same place at the same time. Who can give me an example of a population then? Who can give me an example of a population living in the same place at the same time?
Humans.
Humans is an example of a population, even though I don't like using humans as an example. What's another one? That's a good one, though. What's another one?
Cats.
Cats. Cats in a house. What's another one? Let's think of outside. What's it? Birds. We can do that one. What about oak, trees, and a forest? Okay, the forest itself is not a population, but the oak trees in the forest is a population of oak trees. Okay? So there's just some good examples of that. Now when we get to a community, let's take a look and see if I can do now a new color here. Text color. Oh, there we go. Okay. Text color is red. A community now is a group of different populations. We can put in parentheses then organisms living in the same place and same time. Is this big enough, by the way? A group of different populations are now different organisms living in the same place and same time. Who can give me an example of different or of a community then?
Rainforest?
I'm going to say no because we've gotten a little bit too specific now. But I'm glad that you said that. We could go with all of the trees in a forest. So instead of looking at just one tree, we're now looking at all of the different types of trees, huh?
Bears.
Bears is still a population, right? It's one single.
There's different kinds though. There's different breeds, like types. There's brown bears, black bears, polar bears.
Okay, so we would have to say then different species of bears living at the same place. Okay? What else? Ocean is an example of a community. What else?
Cats and dogs.
Cats and dogs. Lions and tigers and bears.
Oh my.
Thank you. You need to say a little bit more gusto though.
Oh my.
Thank you. There we go. All right. I can't spell forest. Okay. Good. Now, ecosystem. The ecosystem now is a group of communities living together in the same place and time, along with all of the abiotic factors. All right, so now when we get to ecosystem, we need to make sure that we're adding then along with all of the abiotic factors. That's the important part. So we've now added then the things like temperature, wind, humidity, moisture, soil, all of the things that are non-living which make up the park. Now this is where we start talking about the forest or the rainforest as an example. Because the rainforest now brings in then the rest of the abiotic factors. We are now actually talking then about, okay, we're now actually talking about different ecosystems. Rainforest, this would be the desert, this would be the Arctic, this could be the prairie. Okay. I always forget, is desert one S or is desert one S?
Dessert is 2 S's.
Desert is 2 S's? Alright, so there's the desert, Arctic, prairie, right? All of these things then, forest, all bring in the example of the abiotic factors now. As we grow and expand this process out, it gets more and more complicated then. So as we go back and look at our picture then, right, we're seeing that as we go from our individual organism to a population, a group of the same species, to then a community where now we're looking at ostriches and zebras and gazelles, and that's probably a wildebeest or something like that. And then we go all the way to the ecosystem level where we're now looking at then the abiotic factors that make up then this African savanna. So we couldn't actually say the African savanna for our community because that actually brings in the abiotic parts where the communities are just looking at the biotic parts. Does that help to make that difference, that clarification between, especially between community and ecosystem? So, next part, when we're looking at our ecological relationships, and really what we're looking at are what we call symbiotic relationships. The prefix sim equals together, and the prefix bio means life. So when we look at that term symbiotic, it means living together. Things that are living together. Okay, they're connected. They are related to each other. And in particular, we're talking about, in a symbiotic relationship, primarily we're also talking about now how two organisms work or are related to form a gosh. Okay? That would be our actual definition to a symbiotic relationship. Two organisms related together to form a relationship. And we've got a couple different types of then ecological relationships that we can put together here. And you've probably looked at some of these already, and maybe you have, maybe you haven't, but we'll talk about them really quickly. A predator-prey relationship. Come on. Cursor, get down there. Predator-prey relationship, where one organism is going to eat another organism. The predator is doing the eating, the prey is being eaten. Right? You got that part. Basically, what we're starting talking about when we're looking at our food chains and food webs are these predator-prey relationships. And we can come up with many different examples of predator-prey relationships. The classic kind of predator-prey relationship is the hare and the lynx. Or we could go with a fox and a wolf. Okay? All of those things then, where the hare is the thing being eaten, the lynx is the thing doing the eating. Now, with these things, then, one of the things I'm going to add into this is that when we look at a graph, a population graph of a predator-prey relationship, we're going to find two different things. One, we're going to find how the population fluctuates over time. That's going to be our hair. We can then also see that how the predator relationship or population will change over time as well. And it basically mirrors the prey relationship. So what we're seeing then is as the hare population is starting to increase, as there's plenty of producers and resources for the hare to eat, so does then the lynx population go up because there's now more hare for the lynx to eat. At the top then, as the number of resources decrease, the number of producers are decreasing, and then also to the amount of hare, there's not as many hare left, their population starts to decrease. So does then the lynx population decrease. Now we get down to the bottom again where there's more producers, more plants, there's less lynx, so now the hare population can go up and grow, and the same thing will happen then right afterwards with the predator population. We will find this same type of graph, this same type of population graph for any predator-prey relationship that can be found. So this is not unique to just a lynx and a hare. This will be found with any type of predator-prey relationship. So, and again, that was the hare is the green, and the lynx is the blue, or the predator is the green, and the prey, the prey is the green, and the predator is the blue. Okay? So, we can see then how those two relationships work together. You want me to leave that up there? So you can copy that down? Okay? Just out of curiosity, is the typing going a little bit easier for you to see and to read? Is that helpful? Okay, good. The lecture is also getting videotaped, and I will then put this on in today's thing for the YouTube or for my Canvas. I'll also then put a link for this video lecture in there as well so you can see it. Okay? So if you need to go back and get some notes or you don't understand something, you can go back and look at the lecture, or you can use some of the resources that are also there as well. Can I erase this now? No? Wait a second. Okay. Probably, I am going to need to erase it before I continue to keep moving on, but I think I can make this work. So, mutualism. So now we're going to look at a mutualistic, what we call a mutualistic relationship, or a mutualism symbiotic relationship. And that's where two organisms, a relationship between two organisms where they both benefit from being in the relationship together. They actually have to be together and they benefit each other from being together. We can kind of look at that as a positive and a positive. So each organism benefits from being together like that. A really quick example of that is going to be bacteria in a cow's gut. A cow eats grass, and the grass is indigestible by the cow itself. It can't actually absorb any nutrients out of it. So the bacteria break down the grass, it breaks down the cellulose in the grass into a usable product that then the cows can then digest. The bacteria get home, they get food, and now the cow then gets the grass broken down into a form that it can use. That's what we call a symbiotic relationship, where both organisms can benefit from being together. There's a couple of other examples that we can look at that. Is we can go then, example, we can go cow and bacteria in stomach. Another example of a symbiotic or a mutualistic relationship is you could say bees and flowers. Is the fact that both the bee and the flower benefit from being in that type of relationship together. They don't have to live together. The flower pollinate, or the bee pollinates the flower and helps the flowers to reproduce. The flowers produce nectar for the bees, which they take back and to turn into honey to help feed the rest of the hive. So they both benefit from being together. Should I make the text bigger? Actually, you're still small, right? Okay. That's all I needed to know. Thank you. So, does that help?
Yeah.
Okay. So now I gotta move this down and I gotta erase that. So, let's do that really quick. All right, last couple. Commensalism. Commensalism. Let's make this nice and big so we can all read it. A relationship between two organisms where one benefits and the other
Bunny.
Oh my gosh. Because I'm connected to the smart board, my cursor doesn't want to move, go where I want it to. And the other is neither harm nor benefits. Okay. So a relationship between two organisms where one benefits and the other organism is neither harmed nor benefits. So what we kind of call that is remaining neutral. We can show that is by a plus and a 0. Right? So one organism benefits, the other one is not harmed nor benefits from that type of relationship. The example that we can kind of give to this one, which is pretty simple to kind of think about, we've probably all seen this before, is the clownfish and the sea. Oh my gosh, anemone. I spelled that wrong, but clownfish and the sea anemone. Where the clownfish is the one that benefits, the clownfish gets protection from the other fish, and the sea anemone gets really nothing. It doesn't really get hurt nor harmed by it. Some people think that the sea anemone could actually get a benefit from it by getting food scraps from the clownfish. For the most part, you can look at it either way. A lot of times they'll give you examples of both for being commensalistic and mutualistic. But I think you could do a clownfish with that one as well. So, here we go. Our last one then is parasitism. And this is where one organism benefits from the relationship and the other is harmed. Sorry. And the other one is harmed. We can think about that as a positive and a negative then. The easy example of that is we can think about, there's a lot of different examples that we can put into this one. Mosquito, tick, leech, tapeworm are all examples where then they are affecting the host. They are actually using the host to stay alive, and the host then ends up getting harmed in the process. Now, ideally, then that organism doesn't want to kill the host, because if it kills the host, then it dies. So it doesn't want to actually destroy it, but it does want to use it. Okay? And we can think of all those different examples. Mosquito, tick, leech are all using it for blood in order to stay alive. The tapeworm actually just eats your food. So it stays alive by attaching into your stomach, and then it's digesting the same food that you're eating, and that's how it stays alive. So, some pretty easy ways to kind of keep thinking about these things. So again, these are just showing you relationships between different organisms. Did anybody need any more time? Did you get them all of it? Did that help with the typing? Make it a little bit easier for everybody? Okay. Any questions about them? This lecture then today, just so that you are aware, if you needed to, relates to worksheets that can be found in 4, 5, and 9. Okay? So if you're looking to then to capitalize on things that you just got done learning today, 4, 5, and 9 are the worksheets then that'll help you with that. Otherwise, if you don't have any other questions, I'm going to give you the remaining half hour of time to work. Okay?